Okay, first question, when zinc is oxidized. So before we do any of these questions, we need to make sure we can recall what is oxidation. So oxidation means either it gains oxygen, it loses hydrogen, or it loses electrons, or there is an increase in oxidation state. So now we're talking about oxidized, that means oxidation is taking place. So it could be any of this. So when it says here, protons, cannot be. Electrons are lost, seems correct, right? Then there is this one that says configuration becomes 2.8.2. If you look at the periodic table, zinc has 30 electrons. So if it loses electrons, if it loses 2 electrons, it will be 28. This is 12 electrons. There's no way you can lose from 30 electrons to 12 electrons. So it's wrong. Okay, and hydrogen is added. That is not oxidation. Oxidation is losing of hydrogen. Okay, therefore, question 1, answer is B. Simply based on this information over here. So next, which one of the following is oxidation reaction? So same thing. Okay, we look at the question and see what they ask. So this question here has all this. So we see whether we can tell whether there is a change in oxidation state. Okay, so here we will look at oxidation reaction. So it will mean it is increased in oxidation state. So let's check and see. Okay, how do we know oxidation state? We look at the charge, right? So N3 minus means the oxidation state is -3. And when it's an element, a free element, the oxidation state is 0. So -3 to 0 means there is an increase. So when it's an increase, it could be oxidation. So A could likely be the answer. Okay, and it is the answer. But you can check and move on. So here, charge is 3 plus. Oxidation state means it's +3. Okay, the number goes behind for oxidation state. Free element is 0, so +3 to 0, it decreases. Here, same thing, 2 plus, so OS is +2. Free element is 0, so +2 to 0, it decreases. So both of this is not oxidation. Then how about the last one? Sulfate ion to sulfur trioxide. So here, OS of oxygen will not change. OS of oxygen is -2, but sulfur will change. So let's take a look at our working over on this side. So because there is 4 oxygen, OS of oxygen is -2. So it means this will give us -8. And the overall charge is a -2. So this has to be +6. Because +6 and -8, the excess will give you -2. As for this one, again, charge of oxygen is 2 minus, so OS is -2. There's 3 of it, so it gives us -6. So the whole OS of a compound will give you to 0. So this has to be +6. +6 minus 6 gives you 0. So the OS of sulfur is +6 for both, which means there is no change. So answer for question 2 will be A. Okay, next. Question 3. Which substance in the reaction is oxidized? So here, this is the reaction. So this seems a bit clear because if you look from carbon to carbon monoxide, it has gained oxygen. So this means that carbon has oxidized. So answer is A. Okay. Next one, which substance in the reaction is oxidized again? So let's look at the question. So this is the question over here. Okay, here in this question, if you look for gain oxygen, it is not easy to see because oxygen is only in sulfate. If you look at lose hydrogen, it's not very clear to see as well because though there is hydrogen was previously with sulfate, but now sulfate also appeared here. So you can't just conclude that this has lost hydrogen because there's another sulfate partner. Okay, so it's not as easy to tell. So what we do is, since we can't look at the loose electrons, we will look at the oxidation state. So for oxidation state, let's look at iron sulfate first because it's easier. So sulfate as a polyatomic ion is 2 minus, which means that the charge of this ion to balance out the charges to get iron 2 sulfate will be Fe2+. So this tells us that the oxidation state of iron is +2 in this case. Okay. Now we look on to this one. We look at our compound first. So this is our sulfate ion, SO4 2-. And we need 3 of this sulfate to balance the charge. So here, there's only 2 of this. So this ion has to be 3+, because if you check, 2 of this Fe3+, here, let me write it down to be even clearer, you get 6+, right, to form the chemical formula. Sulfate ion, there's 3 of it. So SO4 2-, SO4 2-. Here you get 6-. So this is where we balance all our charges to get the chemical formula. So we know that the charge of iron has to be 3+, which leads us to know that if the charge is 3+, the OS of iron has to be +3. So before you even do the rest, you can tell that from +2 to +3, there is an increase in OS. So for iron, +2 to +3 is an increase in oxidation state, which means that yes, oxidation has taken place for iron, and this is the one that has oxidized, FeSO4. Okay, if you want to continue and try the rest, you may do so as well. So just to give you a hint, for example, chlorine is a free element here, so chlorine will be 0. And then you check chlorine over here, hydrogen is plus, H+, right? Chlorine is Cl-, right? So hydrogen OS will be +1. Chloride or chlorine OS will be -1. So for chlorine instead, from 0 to -1, chlorine from 0 to -1 is a decrease in OS, which means this is being reduced. So this is a redox reaction because we have something being oxidized and something being reduced. So let's not waste any more time and look at the question for the answer. So answer this is iron 2 sulfate. So answer is C. Okay, next one. Reaction between iron 3 ions and iodide ions. What is the question? They say which statement is correct. Okay, so before we even move on further, this is 3+, this is 2+. So if the OS we say +3 to +2, we will say that it decreased. So iron has reduced. Okay, so iron has reduced. Then we look at the next one, I- to I2, free element. Okay, so OS of I- is -1, OS of a free element is 0, so there's an increase in OS. So for iodine, it has been oxidized. So now we look at this. It says Fe3+ ions are oxidized. Nope. Okay, Fe3+ is being reduced. This is being reduced. So Fe3+ are being reduced. Sounds correct, right? Then we check. Reduced. Okay, if oxidation is losing electrons, then reduction will be gaining electrons. So this is perfectly right. Okay, so the answer would be B. If you want to check the remaining, you can do so. I- was being oxidized. See, oxidized. But oxidation is losing electron, not gaining of electron. So this is wrong. It should be loss. Okay, so that's why answer is B, because B is the only correct statement. Okay, next one, they give us a reaction and they give you many statements. Okay, so let's look at the reaction first and see if we can tell what happened. So hydrogen sulfide has lost hydrogen, so this is oxidation. Chlorine has gained hydrogen. Okay, chlorine has gained hydrogen, so this is reduction. So loss of hydrogen is always oxidation. So we know what has been oxidized, we know what has been reduced. Now let's look at the statements. Chlorine oxidized, wrong. Chlorine oxidized, wrong. Hydrogen sulfide oxidized, correct. To sulfur, correct. Okay, so therefore the answer is C. Alright, if you want to look at the last one, oxidation number, Hydrogen here is +1. Same for hydrogen is always +1. Oxidation of hydrogen usually is always +1. Okay, now we move on. Which of the following underlying substance is reduced? So reduce, we are talking about not increase, but talking about decrease in oxidation state. Okay, so we want a decrease. So if we look at this question, I need more space, so I prepared it here. So, okay, so let's look at the options. So hydrogen is always +1, so 3 of +1 will give us +3. So this has to be -3 because the whole compound has to be 0. Oxygen is always -2, so nitrogen has to be +2. So what has happened is my nitrogen, the OS, has changed from a -3 to a +2, which means it's an increased. Okay, what we are looking for is a decrease. Okay, so we move on to the next one. So this is ammonia. We don't have to do it again. Based on here, we know that ammonia nitrogen is -3. So this is -3. Okay, here, oxygen is -2. There's 3 of it, which is -6. So if this is -6, this has to be +6 because it will give me a total of 0. So here, my nitrogen has moved from -3 to +6. Again, it is an increase in OS, which is not what we want. Then we move on to the next one. So NO2, this we haven't done before, so we got to do again. So 2 of oxygen, which is -2. So 2 times -2 will give me -4. So this has to be +4 to give me a total of 0. NO3 we did it earlier, so no need to repeat. So this is +6. So what happened here, it is nitrogen from a +4 to a +6. Again, it is an increase in OS, not what we want. Now we look at the last one, nitrogen, N2. It's a free element, so this will be oxidation state of 0. Ammonia we did before, which is -3 for nitrogen. So nitrogen have moved from a 0 to a -3. So this is a decrease in oxidation state. And this is what we want. We want a decrease. Okay, therefore the answer is D. Okay, because it is a decrease. So answer is D. Okay, next one. There's this reaction over here. And they ask you, which describe the change of magnesium atoms to magnesium ion. So if we look at the atom, for a metal to become a positively charged ion, it must have lost electrons. So when we lost electrons, we call it oxidation. So first of all, we find for the word oxidation. So it's oxidation, yes. And is it because it's a loss of electron? Yes. So answer is B. Okay, so next question over here. Oxidation state of nitrogen. So like what we did earlier. Hydrogen is 3 and it's always +1. So this will give us a total of +3. So the whole compound has to be 0. Therefore, my nitrogen has to be a -3. Okay. So that the whole thing gives us a 0. Next one. O is the charge of oxide is always 2-, so the oxidation state is -2. So for my nitrogen, it has to be an oxidation state of +2. Here, be careful, there's a minus over here. Okay, so this is NO3-. So my charge for my oxygen is always -2. Okay, so 3 times -2 will give me -6. So I need a bit more space here. This will give me -6. And the whole thing gives me a -1. So what is it here that can give me a -1? So it has to be a +5. Okay, so therefore oxidation state of nitrogen here is +5. Okay, so now when they ask you to define oxidation in terms of change, what kind of change? So you must say that it's increase in oxidation state. So we write it in words. Okay, and this would be your answer. Okay, next. Underline the formula that has been oxidized and give a reason. So let's look at this one. Okay, so here we have this happening. So we take a look. Can it fulfill any of these four? So if you notice from zinc, an atom to a positive ion means that it has lost electrons. So definitely this is the one that has been oxidized. And what would the reason be? Is because it has lost 2 electrons. 2 plus means lost is 2 electrons. So that is my reason. Okay, so my reason is zinc has been oxidized as it has lost 2 electrons. Next question. Okay, so again you spot and see if you can tell which one. So here there is no oxygen, there is no hydrogen, and we don't see any obvious losing of electrons. So it must be talking about oxidation state. So we talk about oxidation state, okay, K, potassium is always K plus, right? And I is minus. So potassium will be plus 1 and I will be minus 1. So let's compare potassium and I on this side first. So potassium here, K plus Cl minus. So potassium here is still plus 1. So no change for potassium. For I, this is a free element. So this has become 0, which means my I has changed from minus 1 to 0, which is an increase in oxidation state, which matches this. Okay, so because of my oxidation state of I changing from minus 1 to 0, this is the one that has been oxidized. Okay, so I underline it and I write the whole thing down. So I say potassium iodide has been oxidized as the oxidation state of iodine increases from minus 1 to 0. Okay, next one, part C. So here you can tell there is oxygen involved, and CO obviously gain oxygen. So this is rather easy. Okay, so carbon monoxide has been oxidized as it gained oxygen to form carbon dioxide. Okay, and our next one here. So here we have NH3 and so on. So if you observe, you may seem to see that this has lost hydrogen, right? Because the only partner of hydrogen is nitrogen, and it appears only here, and it looks like it has lost that hydrogen. Okay, so you can underline it, then you will write down for all these above answers. If you have explained it in any other way, for example, explaining this two instead of gaining oxygen and losing hydrogen, instead of using this, you state the oxidation state of the substance, whether it increases, okay, that is also accepted. Okay, now we have this equation and they ask you to state which is being reduced. Okay, so reduce is the opposite. That means it's either losing oxygen, gaining hydrogen, or the remaining. Okay, so here we can have a quick one where you can see this to this loses oxygen. So that means that iron trioxide has been reduced. So when they ask you to state the substance reduced, you can simply write Fe2O3 because they didn't ask you to state the name. But if you want to know the name, this is iron trioxide. And the reason is because it has lost oxygen to form iron. Okay, and that's it.